questions from the test that um, that a lot of the class struggled with. There's only so far only a couple for you today, so if there are particular things from the test that you want to look at, um, that might be more efficient. Um, since now there's only 3 of you. Alan went away. Maybe he'll come back. So the one I wanted to start with was this one. It was the one that more people than any other problem. This was one of the lower ones. So take a moment and go through what you either what you tried to do on your test or what you would do now and see what you get. Let's see. And the numbers on yours will be likely slightly different. So don't let that worry you. Everybody's numbers were a little bit different. I'm actually looking at all of yours, see how you all did on this question, since there's only a couple of you. But yeah, this was the lowest problem on the test. I think 54% of people got it right. So it's really low. So I want to make sure we look at it. Alan's back. Yay. So relative frequency, you may remember, was the ratio between our frequency. Yeah, let me make that actually neat. The frequency of our particular class or group, frequency of the particular category or bin. I'm going to use bin. Frequency of that bin in ratio to the total what do I want to call it? Total, of the total of the data, total of the let's say events. Basically, the part we're talking about over the whole. Anytime we're looking to find probabilities, ratios, things relative to other things, it's part over whole. So frequency of that bin over the total in all the bins. Oh, like that better. The total of all bins. So we essentially need to know how many students we have in total. So we have to first add all these up. So we're going to get what, 10, 19, 21, is that 31 in this particular list? That's 9, 10, and 12, 12. So 31. So whatever we're asked to find the relative frequency of, it's going to have a whole value, a denominator of 31. So then what are we asked to do here? Based on the frequency distribution above, so based on this, find the relative frequency of the class with the lower class limit of 23. So the class, or I've said bin up here, with a lower class limit of 23. The class with the lower class limit of 23 is this class. This class is everything from 23 to 26, so its lower limit is the 23. That has 6 students in it. So the relative frequency is those 6 students out of the 31. So we technically could just say, 6/31, but we were asked to round to 1 decimal point if we have to. So it probably, it wants that as a numerical value. It is giving you a little note there that the box already had the percent symbol there. So it's asking you to give that raw percentage, but not put the percent symbol on it because the percent symbol is already there. So 6 divided by 31 is 0.19. So it's 0.19. I'm going to say 194, which that's the decimal form. The percent form would be 19.4%. So 19.4. It was technically, well, let's see, 0.19354837871 and so on. But rounded it so the percent would look like 1 decimal place. So what is the relative frequency of students in that class? Well, 19.4% of the students are in that class. Questions about that problem?
This is from the sheet of paper that we turned in?
No, this is from the test.
Oh, that test.
This isn't necessarily the one you would have had. The numbers get kind of randomized in them, but the process was on the same. We're just going to look at some of the test questions that either you guys would like to look at or the ones that got the lowest percentage successful in my data analytics here. And this one, as I said, I have it in front of me here. It's 52%. So only about half the people were happy with this question.
Yeah, I don't care if I ever see that test again.
Well, then we'll pretend they're from something else today. So any questions you guys about this problem? Leslie or Grace, Olivia, Andrea?
Yeah, I'm good on it.
Okay. So you want me to go to the the ones that were highest percent or lowest percentage successful here, or are there particular ones you guys want to look at that you know of?
Lowest percentage, because I'm probably one of them.
That's fair. Let's see. The next lowest one was one of the dreaded essay questions. Oops, that's not what I wanted. I want that. Oops. Sorry. A lot of people didn't do terrible on this question, but there were some common issues. Now, depending on the version of the test you got, this problem was either on, what was it? Statistics tests for students, whether they pass or fail, whether German workers take the train to work or not. And I think this one with the incoming freshmen was the third version. So you might have had one of those. The question was basically the same idea, just the specifics were a little different depending.
Yeah, I got the train one.
Yeah, the train one. Yeah. I think that was the most common, but one.
And I don't remember this actually being a topic of our previous work.
It was actually our first or second day talking about what a individual population and sample was. So it was a while ago, unfortunately. So suppose you want to know what high school freshmen are particulating, or freshmen at a particular college come from. Your goal in your survey or your goal in your process is to estimate the percentage of incoming freshmen who come from a particular high school. You take a sample of 200 incoming college freshmen. So for our problem, what in our problem we want to know is considered our individual, our sample, our population, and your variable. And you might remember when we were discussing this, we had a diagram. It had a particular person or particular data set. That was our individual. A bunch of those came together to make our sample. So if you had a bunch of those individuals, they would make the sample. And that sample was supposed to reflect, ideally, the overall population that you were studying. All those people in your population. So in this problem and all of the problems, we're essentially asking a person something, whether they take the train or not, whether they came from this high school or not, whether they passed or failed the statistics final. Ooh, there was another one on whether or not they got the flu. So it was all about asking a person a yes or no question. So in each case, the individual is a single person. In this case, the people are incoming freshmen. So a single incoming freshman. We're not taking our survey data from an entire class at once. We're not taking it from an entire group at once. We're getting individual yeses and nos from individual students. So each individual in our study is a individual particular student. Say, as opposed to if our survey was, like say they asked the instructors to find out how many students in each of their classes were from this school. Then that study would be individual classes, and each individual class would be sending a value for how many students. So the individual is specific to what are the particular values coming from. Our particular values are coming from single incoming freshmen or individual incoming freshmen. The variable here, the variable is essentially what we're asking them for.
Which high school?
We're actually not asking them what high school they came from. To estimate the percentage of freshmen who came from this particular high school. We don't actually want to know what high school they came from. We want to know, did they come from this specific high school? It's essentially a yes or no question. That's being fairly particular. If you ask, the variables, what high school you came from, and then you ignored everything that wasn't this particular high school, that would be certainly reasonable. But essentially, it's a whether they came from this high school or not. So our variable we are looking for, or our variable is, or however you want to start that sentence, we are looking for if that student came from BHS.
Brookings Harbor High School.
Yep. Barrington High School. And essentially our variable is a yes versus no question, or Barrington High School or other. There's only essentially two possible answers, either yes, they fall under our category, or no, they don't. And for all of the questions, all of the different versions of this question, that was essentially the variable. For the flu shot question, it was, did they get the flu? Yes or no, was our variable. For the workers in Germany, it was, did they take the train? Yes or no. For the stats students, it's not their score on the test, it's did they pass or did they not pass? Yes or no. And that distinction can be fairly subtle, but it really does change the tools that we are going to look at, particularly this distinction between a numerical value. For example, what the student's score was on the test is a numerical value versus what we'll call in chapter 6, a binomial question, a distinction between two answers, yes or no, but a distinction between two possibilities. This is not a numerical value question. This is a yes or no question. And distinguishing that is going to tell us what tools we need to use on things in this question. Sample usually went fairly well. Again, the biggest thing with a lot of these was it's got to be in a nice complete sentence. Not even a nice complete sentence, just a complete sentence. So what's the sample here? Well, the sample are these 200 incoming freshmen. I didn't get too terribly grouchy if somebody just wrote 200 incoming freshmen. I gave them, the points for that problem, but not the points for having everything in a nice sentence or in a sentence. So putting that in a sentence is fairly important. Answers for the sample like 200 is incomplete. 200 what? So you do need to be fairly specific on these questions. So what is the sample? And I'm just writing, as simple sentences as I can here. The sample is the 200 incoming freshmen. And you could certainly say that were surveyed and asked this question if you want to. Heck, you could just say it is the 200 incoming freshmen, and that's a complete sentence. You're good. Population, similarly, population tended to go fairly well. So the population here is all incoming freshmen. That says incoming freshmen at that particular college. One of the things that happened a lot you might want to look for is a lot of folks had the same statement for the individual as they did the population. So the individuals make up all of the incoming freshmen, but the individual is a particular incoming freshman, as opposed to all incoming freshmen as a group. So there's a fair amount of subtlety in those, and those distinctions are actually going to be real important, which is why I wanted us to talk about this and why we looked at these things in chapter 1, because it really does, some of those subtleties distinguish between the tools that we're going to have to use. So being able to identify that this is a binomial question, for example, is going to be super important. Questions about that?
I heard that.
I know. I wonder what that was. Was it the dog or the daughter? It's hard to tell. Okay, as I'm going to probably ask you guys every time whether or not if there's something particular you'd like to look at, or you want me to grab just the next one on the list percentage-wise.
Yeah, just keep pulling them.
All right. Let's see. Oh, this one's fairly quick. So the taco problem.
Tacos are never a problem.
Unless there's not enough of them. So the big issue in this question is that at least language. I did go through and look at the different things that people put. So if you got this question wrong, it started off just saying, you're wrong, you don't get anything. But I went back through and looked and kind of like, okay, that number would have come from doing it this way. So here's a couple points back, and this would have come from doing it that way. Or I have no idea where this number came from. I just left it. But that at least language, I think, is where most of the issues came from. So if you have, what orders include at least 3 tacos, certainly the bar for 3 tacos is going to be included in that list. So if you ordered 3 tacos, that means you got at least 3 tacos. So there's going to be those 12 people, to be sure. The issue then is, do we count down? Do we count all the ones with 2 and 1, or do we count upward 4, 5, 6, and 7 plus? Now, at least 3 tacos, if you have, say, 2 tacos, is 2 tacos at least 3?
No.
I don't know. That's not enough tacos. Who wants just 2 tacos? At least means that's the lower bound. So at least 3 tacos is 3 tacos or anything higher. So we've got to add in this bar, this bar, this bar, and that bar. So it's those 12 plus these 15 plus those 12 for 5 tacos, all 7 of the orders of 6 tacos, and all 5 of the orders of 7 tacos. Each one of these orders had at least 3 tacos in them. So how many is that in total? 36, I think it's 41 orders had at least 3 tacos in them. So you just had to write the answer 41, but it would have been nice, I think, if the problem, made you write it in a sentence, but 41 orders included at least 3 tacos. So as I said, the biggest error tended to be, instead of counting up, people counted down. So they would add those together and get the lower amount. That would be the frequency of at most 3 tacos, as opposed to at least 3 tacos. I think it's common to see that word least and think about less and want to go that way. But again, at least means that's the lower bound, and we want everything that and above.
The more tacos, the better.
Yeah, always more tacos, the better. So depending on what you put there, I tried to give points for, like, okay, you knew what you were reading, you just went the wrong direction. Versus I have no idea where the number came from, or some people I think were giving percentages. So there were some weird answers, but there were a lot of very sensible answers that were just the wrong direction a bit, and I tried to give some points back when I saw that. Questions about that?
I'm pretty sure I got that one.
I don't know, I could check. So let's see. Screen interpret at least, that's that one. Looked at those. Well, I suppose it's hard to put off. Oh, it's handy. Where is it? Oh, there it is. Okay, sorry, looking for that question. Certainly at some point we have to look at some of the bigger ones. There we go. So let me grab one of the bigger ones. Or one of the bigger ones anyway.
Yeah, this one.
Yeah, to just bring good feelings back for everybody.
Yeah, I'm slightly going into tremors at the moment.
So this was certainly a problem that a fair amount of people struggled with for different reasons. Again, I went back through and kind of, if I could figure out, okay, that I see what you were doing there. I tried to give some points back for it, but yeah, a lot of folks struggled with this, and there's a lot of things in this problem, so that's not unusual. So there's a couple different ways we could start doing this. You certainly could have used the calculator and or Excel to help out with it. But for this format, I think I just want to look at the problems individually, or problems look at the stuff by hand, not get the tech in the way. But if you want to look at doing it with the tech, let me know. So since we're talking about interquartile range, that means we're going to be talking about medians and quartiles. So having this be an ordered list would be handy. So I think taking the time, either again with the sort on the computer or on the calculators, it would be nice to have this list in order. So I'm going to take, oops, that's not the first one.
It would have been nice.
It would have been nice. So 463.2, 470.5. Ooh, so 468 in between there. There's a lot of low numbers in this one. Again, your numbers will have differed, but the problem setup will have been the same. Anything else in the fours? Okay. So in the fives, the lowest one looks like that one. So 515.1.
Basically, what you're saying is we all had nightmares. It's just some of us have different nightmares.
Yeah. Yep. 506 has to go first. And, you know, this is one of the reasons why putting this in the calculator or Excel is nice, because it's just easier to sort that way.
I didn't actually know how to sort it into the correct, I was able to put it in, but I was not able to sort it into the correct order in my calculator.
Oh, if you go to edit, where you put it in the data, that first screen, there's a sort A that sorts in ascending order. So you can just sort ascending list one, and it sorts it. I think it's easier to sort in Excel, but
yeah, I went looking for it, but I couldn't find it. But I knew it was in there.
Yeah, it's under the edit subcommand. Because doing this by hand is a little irritating. 626.2. And then 664.3 and 736.3. I have a thing on my screen over there, so I have to write them down. 791.4. Okay, so that's our list in order. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points. So 13 plus 1 divided by 2 is 7. So 1, 2, 3, 4, 5, 6, 7. That's going to be our median. So our median, or Q2 if you prefer, is the 57.4. Whoops, the 571. Clean it up. 571.4. Okay, I just want to make sure everybody's happy with that.
Ecstatic.
Maybe I should say comfortable with that. And you'd say snuggly or something. So 571.4. Okay, so to find the interquartile range, we need the other quartiles. So that means we need to take our lower list here up until, but not including, the 571. So that's 1, 2, 3, 4, 5, 6. So that value is going to occur in between those two. So our Q1 is going to be the mean of those two. So Q1 is going to be the 470.5 plus the 506 divided by 2. So we got to figure out what that is. Q3, similarly, for the lower data set. So for this data set, it's also 1, 2, 3, 4, 5, 6 values. They should always be the same length. That's why we have to exclude that point in the center. So it's going to be the in between the third and the fourth term. So that's going to be the 626.2 plus the 664.3 divided by 2. I think the thing that makes this question the more difficult is just the fact that there's so much that we have to do before we can start answering the question. We got to put it in order. We got to find the median. We got to find the quartiles. We have to do a lot of prep work before just finding that data or finding the answers to their questions. So 470 point, I'm putting this into my little calculator here, plus 506 divided by 2. So that's 488. I lost it. 488.25 for Q1. And 626.2 plus 664.3 divided by 2. 645 and a quarter. So before we can find what the IQR is, we've got to do all of that. Or have the calculator do all that, or have Excel do all that. But we need all that information before we can do part A. Then to find that IQR is that interquartile range. It's that difference between the inner quartiles. So the 645 and a quarter minus the 488 and a quarter. So I'm just going to put the 488 down here and do a little old school subtraction. So what's 17, 5, and 1. So 175. So the 157, sorry. So 157 is our IQR. So I know a lot of you fought quite a bit with or struggled quite a bit with IQR, questions about where that IQR came from, what we had to do to find it.
Yeah, for some reason I have a hard time remembering that's the way to get it.
Well, it's unfortunate in some ways that we often call it IQR. I think focusing on that, interquartile range and what that's saying, the interquartile range. So the range, the distance between the inner quartiles. So we've got the Q0, Q1, Q2, Q3, and Q4. So these are our outer quartiles. These are the inner quartiles. So it's essentially asking, how long is that box? What is the range between all of those inner pieces? So our IQR is physically that length of the big rectangle in our box plots. So I think trying to visualize it can help. And that might not help, but it might.
Yeah, just remembering to break the number set into quarters or whatever.
Yeah, and that's that focus on that quartile means break it into quarters. Range means find the distance. And the inner means of the, the inside ones. So the inside quarters, how long are they? Sometimes I think interquartile range, it sounds cool. I like saying interquartile range, but sometimes I think it sounds too highfalutin, that people tend to not think about what it says. It's just a label. It sounds all serious. Be fun to say. Now, sample standard deviation, if we wanted to calculate that by hand, we'd need the mean. We're going to need the mean later anyway, but I certainly don't want to calculate that by hand. So we'd grab either the calculator or Excel and tell the calculator or Excel to do that. Most people, I don't know about any of you guys specifically, but most people who struggled on this question, the one they usually got right was that standard deviation. So do any of you have any questions on how to find the standard deviation using Excel or a calculator? Or can we just say, ask the calculator, ask Excel, and that's what it is?
It's the SX.
Yes, on the calculator, the SX.
Pretty sure I got that one.
What's that, Alan?
Pretty sure I got that part of it right.
As I said, most folks did. While you've got the calculator there, I'm going to ask you, by the way, what is the mean? What does it say the mean is? Or do you have that on your, have you been putting it in your thing?
I got to go get it. Hold on.
Oh, okay. No, I can do it too. I just thought you might have had it right there. Because as I said, we're going to need that later. Or if anybody else there wants to find it real quick, that would be handy too, just to check. I did it in kind of a weird way, so check this. Make sure it looks reasonable, but I did in kind of a weird way on the calculator here. So tell me if anybody else gets that value.
Yep, that's right.
All right, good. Olivia, Leslie, or Andrea, Grace, Micah, you guys getting that value or?
I'm sorry, I'm doing it on the calculator now.
Your what's that?
I'm inputting in the calculator.
Oh, it can take a while to type them in, no question. I can show you a nice trick if that would help. You might not like the trick, but let me see. Oops. But while I've got you here, I might as well show you because it might help. Where's my thing? Zoom, share the Excel document.
You were saying to get these things to go in order, go.
If you hit edit, so
And then sort.
and then sort A will sort in ascending order. So when you
So
bring that,
I've got sort A, and then I've got a beginning of a parenthesis and a blinking light.
so right there, put list 1. So type or hit L1. The second 1 button has L1 on it. Then hit enter.
Wow.
But with Excel, I know some of you guys are not liking using Excel as much, but it is handy for the homework questions and the test questions. If you highlight the tables, you can copy and paste, and it will paste them into Excel. It's not in a nice format in a lot of ways because it's not, in a nice straight up and down column, but it's easier to move these into a column from here than it is to type them into really anything, I think. So just with a little moving them around, you've got them in a nice column. Then you can go to data, sort down, and they're sorted.
Does the school offer the updated Excel? Because I think that's just my issue is that I have an outdated Excel.
They do the 360. So yeah, that one is the same one I have here.
Okay.
And if you guys still need links on getting that, all that stuff is on the school's website, but some of it can be hard to find. I do have a document that they sent me to send out for you guys if you need it. So you can send me a message and I'll send that document out if you need a copy of it. Because it is just super handy. I mean, that's so much faster. If you've got that data analysis tool, and there's that video on putting it on, you can get all of this information really quick. I don't have it on this one. I have it on, this is a separate account on my computer, so this one doesn't have the data analysis tool. But if we want that standard deviation equals stdev.s, again, that parenthesis, and our standard deviation. So I don't, want to say use Excel, don't use your calculators, because you guys are comfortable with the calculators. You like the calculators. The calculators work fine. But the more comfortable you can get with Excel, you'll be able to do a lot of things a lot faster and with a fair amount less work once you're comfortable manipulating it.
Yeah, my only problem is I have to go to the college every time I want to use it.
And that's a very reasonable problem. That's a very good reason not, to use that. And that's why, I want you guys to know how to use both. But it is, for those of you who can, it is going to be helpful. So what? That was 157. That was 103, right? I don't know why it erased my stuff, but it did. The X bar was, what was it?
For what?
Um,
Oh,
on the mean.
103 is your standard deviation, and your
588, I think it was.
581.6, so 582.
So I'm going to go with the 0.6 for right now, just to keep some decimals. Okay. So again, we're going to need that later, so we have to have that. We found the quartiles. Again, I don't know why my thing erased that, but what was the Q1 and Q3?
I got 582.3 for the mean.
Ooh. We're going to argue about means. I love arguing about means.
Q1 is 482 or 488.
And 0.25, right?
0.25.
And
Q3 is 645.25.
you said you got what for the mean? 582.3?
0.3.
Anybody want to back either of those up?
Yeah, it comes out to the same checksum that it's noted to.
Is that on Excel?
No, it's on the calculator.
Yeah, I can't back it up on the calculator. I got 581.6, which would round up to 582.
Yeah, but wouldn't round up to 582.3.
No.
Well,
Yeah, is your sum the same sum that's on there? Because your Q1 and Q3 is the same one that comes out on the calculator.
yeah, that is always a nice thing to check. The sigma, you'll see at the top of your list there, the sigma x, the sum of all of them. You're told that's
99.0. 99.032.
So it's not the same as that, which means something in there is typed in wrong. That's actually why they tell you what that checksum is, so you can check to make sure everything's typed in by checking your sum. Let's see what I get on Excel. I had to put it all back in. But 582.3, yeah.
Well, in my defense, there were lines over all of those numbers that I had to read.
Oh, absolutely. And it's even without that, it's easy to mistype something. That's why they give you this sum, so you can go, okay, is everything good? Because if that sum is wrong, you got to find out what's not right. So that's why they hand you this, because it's so easy, particularly with decimals in here, so easy to have something typed in that's not quite right. So we have our Q1 at 488.25. We have our median was in between there. Our Q3 was a 645.25. We could find out, we could look at our list and decide what our Q0 and Q4 are if we wanted to, but we're asked to use that 1.5 interquartile range tool to search for outliers and see what the lower and upper cutoffs are. So that 1.5 interquartile range tool, as you recall, says, okay, go from the outer quartiles. So from these quartiles, or the outermost of the inner quartiles. So from Q1 and Q3, we're going to measure out 1.5 IQRs. Anything past that, we're going to call an outlier. Same thing on Q3. We're going to go from Q3 and add the 1.5 interquartile range to get a boundary for anything outside that boundary, we're going to call an outlier. So we need to know what a 1.5 times our interquartile range is. So 1.5 times 157 1.5 times 157. And then we're going to take that Q1 and add whatever that value is. 1.5 times 157. Oh, sorry, not add. Going the other way. We take that Q1 and subtract it to go that direction. And then the Q3 plus the 1.5 times our interquartile range to go in that direction. So 488 minus whatever 1.5 times 157 is. Sorry, 488.25 minus 1.5 times the 175. That's going to give us our low cutoff. And then the 645.25 plus whatever 1.5 times 157 is going to give us our high cutoff or upper cutoff. So
252.75.
252.75. That doesn't seem unreasonable, but let's see if somebody can back you up on that. Somebody either back up or argue with Alan. And somebody else also find me that high cutoff. Alan, you're not allowed to find me the high cutoff. Okay, you're allowed to find it. Just don't tell me what it is.
He was correct. He was correct.
Nice. I trusted him. What good to know. So 252.75.
The high one, 880.75.
880.75. Anybody want to back that up?
I can back that up.
Awesome. 880.7. So anything over 880.75 or less than 5 or 252.75 we'll call an outlier. So if we looked at our ordered list, the highest on our ordered list was the 791. So there is nothing bigger than the 880. So there's no upper outliers. The lowest thing on our list was 400 and something. 400 and was it the 63 or 400? Yeah, it was one of the 400s anyway. It was nothing less than 250. So by that rule, are there any outliers? Nope.
No, sir.
Some common things to have go wrong with this interquartile range tool. Often people will want to add and subtract from that median. So they'll take that Q2 and they'll add and subtract from the second quartile instead. This rule is quite specific. That is a distance measured out from the first and third quartiles. So it's added out from there.
Why is it no if like those numbers aren't even within the Q1 and Q2? So wouldn't it be an outlier because it's not in there? Or no?
Well, we're not asking whether these numbers are outliers. We're asking, are any of these, that was not a good circle, sorry. We're asking, are any of these numbers in our data set outliers?
Oh.
So they're outliers if any of these were outside of this range.
I
they'd
thought it
be
was asking
outliers.
for those numbers that we just found.
Yeah.
That makes sense then.
Yeah. These are essentially boundaries. They're not part of our data set. Our data set was entirely in there. So yeah.
Okay.
Now, I've mentioned a couple times that your book goes back and forth a little bit on its use of language, and that I wants to be much more specific. So I did go in and edit this question that they had to use the language that I was using with you guys and that I want you guys to use. But this unusual values are, our two standard deviation rule for finding unusual values. That's what we'll use for unusual. That's how we will interpret two standard deviations or more, or technically how we'll interpret more than two standard deviations. The big thing to remember is when we talk about means and standard deviations, we're looking more at this kind of model, or kind of shaped curve model, as opposed to box plots. There are really two different ways of modeling the same types of data. It's just we're looking at them from different perspectives. So in our model, we're going to have our middle of our model at our median, and we're going to go out one standard deviation, two standard deviations. So anything outside of that is going to be considered unusual.
And the IQR of 157 is the X.
Is the what, Alan?
The mean.
The mean is that 582 that we found.
Where did we find that?
You guys went and found it on the calculator or on the computer. Remember, you had 581, I think, because one of your values are wrong. But
so the second quartile is not that should be the second quartile, should be the mean then, the halfway.
The second quartile should be near the mean if the data is symmetrically distributed, but that's not necessarily true. One of the things that I try to mention to you guys a lot, but it's tough to do. So it's not, the reason I mention it so much is because it's a thing that can be trouble if we're not careful. We really want to break our tools into two sets. We have our sets for values and our set for position. And we really don't want these to mix. So our means and our standard deviation, those tools go together. So anytime we're using standard deviation, it's going to be connected to our means. So we're never going to measure standard deviation off of Q1, Q2, Q3, our quartiles. Our quartile arguments live in a separate world than our standard deviation arguments.
Well, I don't like that. We need to change that.
Tough. You can change that, become a world-renowned statistician, and change that. But
I'm working on it, but so far I can't pass the class.
Well, that's just step one. You gotta, once you get past that, it'll start rolling. Our median, our quartiles, and our interquartile range, they live in our position-based world. When we're arguing about or making arguments about value, it's means, standard deviations. The problem with those is they're not resistant. If we want to talk about resistant measures, we stay in our position measures. Our median, quartiles, interquartile range, box plots. Those are our resistant measures, our position-based measures. Our more bell-shaped curve, technically you can put the mean in here and technically the median is still in here, but we tend to visualize these, the position with box plots. We tend to visualize the values with histograms. So these arguments will always go together. These arguments will always go together. And there is very little mixing in between. So if we're going to be measuring standard deviations outward, we have to be measuring that outward from the mean. And as I said before, it's one of the things that's tough about this question. In the start of this question, there's a whole bunch of stuff we have to find before we're able to answer any of these questions. So we find the standard deviation, that 103. Well, how are we going to apply it? We have to go back and grab the 582.3 that it never asked us to find. We have to go grab it and add 2 standard deviations up to it to get that bound, and subtract 2 standard deviations from it to get that bound. And how do we know to do that? Well, because that's what the 2 standard deviation rule is. 2 standard deviations from the mean. So we need to know the mean.
206 in each direction.
What's that?
206 in each direction.
Yep. So that plus 2 times the 103, that's your 206, and that minus 2 times 103. So whatever 582.3 plus 206 and 582.3 minus 206. And that's what, 788.3 and harder, 376.3. Is that right? If that's not right, shout at me. If either of those aren't right, shout at me.
Anyone?
Leslie, Grace, Micah, Olivia, are those right? Ever feel all alone in the world?
I do a lot, but only when I'm in math class.
Yeah. Andrea's harder to pick on. She's at work.
Sorry, I know I keep getting picked on at work. I've got my coworkers kind of bothering me in the background. So.
And Andrea, you should know it's a lot of respect for doing both of these things at the same time. That's tough. A lot of people aren't coming to these because they got stuff going on. So the fact that you're taking the time to do that while doing it at work and having to balance that, lots of respect for that.
Thank you. I appreciate it. Luckily enough, I'm able to kind of have this position to try and balance it as much as I can. It's tough, but I'm thankful to be able to at least try and get on here a couple times a week with you guys.
Well, I'm certainly glad you can. I said of the almost 40 students in the class, I tend to see about 6 of them every day, and it's the same, 6 or 7. And it made a big difference in looking at test scores. As did homework and so forth. The particularly homework and so forth made a bigger difference. If you look at the correlation between homework scores and test scores, it more often than not, made a big difference. So,
yeah, I'm the only exception to that rule.
Okay, there were 2 exceptions to that rule, but actually no, there were 3 or 4. Anyway, yeah, there's exceptions.
Your numbers were right.
By the way, right? Okay, good. So for unusual data, those are our bounds. So again, the question, does our data set, this gets back to what you were asking, Olivia, is our data set, does it contain any unusual data, anything outside those bounds? Well, there's nothing low enough. The 376 there's nothing lower than that 376, but there is something higher than the 788. That 791.4 is outside that 2 standard deviations. So is there any unusual data up there?
It's an outlier.
No, it's not an outlier because it is not more than 1.5 interquartile ranges, but it is unusual.
Oh, but it's an unusual outlier.
It's an unusual non-outlier.
Oh,
And I think that's one of the reasons, it nicely illustrates one of the reasons why some of this outlier stuff can be a little bit tough to become happy with, is because we think of, outlier as just meaning it's really big. So outlier, unusual, atypical, all those things kind of end up feeling like they should mean the same thing. But they're not the same thing. There are technical differences between them. They're not words that we commonly use as having a very technical meaning, but unusual and outlier are different. Unusual is defined by 2 standard deviations above the mean. Outlier is defined as more than 1.5 interquartile range from the outer quartile. So you can be like this 791. That's not an outlier because it doesn't follow the 1.5 doesn't fall outside the 1.5 interquartile range rule, but it is unusual because it does land outside of 2. So that's common to have happen. So it is something we want to be careful about. Like, for example, I don't know if you guys can tell, I'm fairly tall. My height is well over 2 standard deviations from the mean. It's unusual, but it's not an outlier. Outliers for heights, you got to be basketball players to have an outlier for height. I am unusually tall, but I am not an outlier tall, not even close.
how tall are
6'3".
Oh, that's almost basketball.
You're
Yeah.
6'3"?
Yeah.
What? That's so tall.
Well, and it is unusual, but it's not freaky. You wouldn't go, holy crap, that person could, as you said, basketball could, dunk standing flat on his feet. So, unusual and outlier, they do have, when we start getting technical in our language, which is what we're trying to do, they do have different specific meanings. So we got to be careful about that. All right. Was this helpful today?
Yes.
Ish.
Okay.
Yes, it was.
Do go through the rest of the questions. You should have it'll now show you what the answers were. So you can go through and check those. If there are some that you just can't figure out, how they got that or what happened, post it in the forums and you guys can discuss it. Send me a message. I can help you with it. So, try to figure out for each of those what the issue was, like what should it have been and why. Don't let it just sit there and be like, oh, I guess I got that wrong. Okay?
Okay, thank you so much.
Sure.
I suppose.
On Monday, we'll start 6.1. So if you're reading ahead, which is always good, we'll start 6.1 on Monday.
So
Okay.
that homework that we were supposed to do on paper and then take a picture or whatever.
Yep.
You got mine?
I can check. I've gotten a handful of them. They're not due until Monday, so I haven't gone through them at all. But I can certainly check, make sure I got it. It is
I
problematic.
did it at the college yesterday and just turned
Okay.
it in from there.
I always think it is kind of problematic that the MyOpenMath system, as soon as you turn something in, it just goes 0. It's kind of jarring.
Yeah.
Mhm.
But
So all the grades from the exam, the first exam, are posted then?
oh yes.
All right, I'll go check out the damage.
Okay, thank you.
Alan, do I have yours? Let me check. Yes, I do.
Okay.
I have your hand in.
Thank you kindly, sir.
Mm-hmm. Olivia, Andrea, anything you guys need?
Sorry.
I was just looking for the handout. Was that on?
I can.
Oh, I just found it.
Okay, good.
Okay. All right. Thank you, and I'll see you guys on Monday.
You are very welcome.
Bye.
Hi, Kim.
Good morning.
Just still morning? Oh, yeah, it is. Wow.
Barely.
Been on this since 7 a.m.
You know, Matt, if you recorded your all the meetings,
Yep.
then I could just get on any time. You wouldn't have to do 2 classes if.
Well, often there's a couple people that sometimes show up at this time.
Yeah.
I do record all the meetings and post them, and usually I record the first meeting. I think actually yesterday I was so off during the first meeting